What's up guys, John here, and I'm going to do a little video on how I test my brushless motors for my little quadcopter builds. So you almost exclusively are going to be using brushless motors like this, and oftentimes you want to test the actual draw that these things are pulling from the battery under load with different sizes propellers or in different conditions, etc., so that you can optimize your quadcopter build. And so I've got a little setup here with a couple different nice little tools, and I'm going to show you what they do and how they work and how I use that to test and improve the efficiency of my motor setups. So if you know how a servo or a brushless motor works, they take voltage from a battery, which goes through, in the case of a brushless motor, an electronic speed controller like this, which takes that current from the battery, converts it to AC, and outputs it in these three wires for the motor. Then it takes a digital PWM signal, which gives it basically a percentage value, if you want to think of it that way, of how much of that electricity that's input to it to apply to the motor. So this is the source of power, and this is the control mechanism, and then this is the output. So what I've got here is a couple things. For one, I've got a 2S lithium polymer battery going through a 5-volt regulator. Super simple setup, just regulating this power output to 5 volts so that I can give it to this little DC device, which is a CCPM servo tester. And all this does is gives a PWM three PWM outputs here, so you can hook this into three servos or brushless motors simultaneously, and that's really handy to have to test out. And then we've got the Turnigy Megameter here. This thing is extremely helpful for testing motors. It can do a lot of things, so we'll get to that in a sec. And then of course over here I've got a favorite Littleby 20 amp opto, so no BEC included, electronic speed controller. And then I've got my Turnigy Nanotech A-Spec super high 60C discharge rate battery. This thing can output, as you can calculate from this, 1 times 60 amp continuous load. So that's insane. I'm going to go ahead and plug this in, which will also start to power the Megameter here. Now, as you can see, this thing can do a ton of things. It can check the individual cells of a lithium polymer battery. It can check the internal resistance of those cells. It can act as a watt meter to measure the current going through this device. It can do a servo testing function where you can apply a variable amount of PWM signal. It has an optical tachometer, so you can check the RPM that your motors are spinning at. It can check temperature. It can do in a thrust. It says thrust calc, but it's a thrust estimation system. It's not going to actually test the pull of your motors with a propeller on them, but it gets pretty close. So what I'm going to use this for in this case is the watt meter. And all this is going to do is give me a live reading of the current running through from my battery into the ESC, into the motor as it pulls power in. It'll give me the peak current, which is what it hit at the maximum time that it was pulling the most power, and then the input voltage, so I can see 12.56. My 3-cell LiPo here is well charged and ready to go. So I'll put that down there. And what I'm going to do is take that digital PWM input that I was talking about for the electronic speed controller, and I'm going to plug that right in to one of these PWM channels like this. So there we go. That's connected right there. And so the last thing naturally is to bring over our motor to test. So I'm going to test this guy right here. I've got my 3 plugs. Great thing about brushless motors, you can plug them in any order. It doesn't matter. If you reverse any of the 2 wires, you'll just change the direction that the motor spins. So pretty cool. All right, and now I'm all set up. So as I turn this potentiometer here, the motor will spin up and give me a live reading of the current that it draws. So I'm going to hold this here just to secure it. Start turning it. So, as you can see there, we pulled a maximum current of about 3/4 of an amp. And that should be fairly obvious. We don't have any propellers on this motor. It's really not doing anything. I happen to have a 3-inch bullnose propeller here, 3-inch by 4.5-inch pitch. And what I'm going to do is put this on the motor that I have the securing lock for and see what kind of current this draws. So let's go ahead and unplug the unplug that motor, give this guy a turn. Get it plugged back in. Now I'll just go ahead and take this off the top. Install my prop. Tighten her down. Now I'm going to quickly just make sure it's going the right direction. It is. Okay. So now let's check it out and see how much see how many amps it's pulling here. Cool. So it looks like it pulled a peak current of about 2.32 amps, which actually is not that much at all. So that tells me that under full throttle, this motor here with a 3-inch propeller by 4.5-inch pitch, which is a relatively aggressive pitch, is not going to pull more than 2.32 amps in its maximum burst. So that would be at full throttle. And so I know that this is not actually using a lot of power. These ESCs are actually rated for 20 amp loads, continuous, and 30 amp burst. So this is how I know, for one, that my ESC will be more than enough to power or to handle the load to power my motors. But I get to make sure my motors work and check out different propellers' current draws through them.